Hey, all you cool cats and kittens. I'm back. We have this week and then 2 more weeks after this of me making videos for you. The same thing we're going to do like we did before. You're going to have your video over scientific notation today. It's for this week. We're going to practice. You have a practice worksheet of scientific notation. I'll send out the worksheet, and I'll give you my answer sheet so you can check to make sure you did the work right. After you're done with that, please do the quizzes game. Join myquizzes.com and type in the code 628051. Also, I would love to see all you guys' face between 12:45 and 1:15. Mondays is second period. Tuesday will be fourth period. Wednesday will be fifth period. Thursday will be sixth period, and Friday will be seventh period. So please log in, ask any questions, or just log in to say hi so I know you're doing okay. I just want to hear you guys to make sure you're doing okay. I miss you all. Let's start on scientific notation. Okay. So, first thing with scientific notation, the reason why scientific notation was created was because of your calculator can only give you so many numbers at the same time, okay? And you can have really large numbers that are too big to fit on your calculator. That's where scientific notation came in. Also, if you don't feel like writing out really, really big numbers, okay, that's when you use scientific notation. Or really, really, really small numbers as well. It's either really big numbers or really small numbers. This concept could possibly be used not only in your math class, but it's also often used in science classes. Hence the reason scientific notation. When you're changing a number from scientific notation to standard notation means it's just written like a regular number. A positive exponent always means that you are going to end up with a large number when it's in standard notation. When it's in normal notation, okay, that's going to be a really big number. If there's a negative exponent that goes with the 10, the negative exponent that goes with the 10, that means it's going to be a very small number, a number that's less than 1, okay? Now, also, when you have something in scientific notation, it is not officially in scientific notation unless you have a single digit, as you can see here are examples, a single digit, not including 0, before the decimal. So like 1.35, that would be an okay number. 2.765, that would be an okay number. Just 3. 3 is right before the decimal. Even though you don't see the decimal, there is a decimal there. 4.57, these are all good examples. The non-examples would be like 13.5. It would have to be in front of that 3 in order for it to work. That's where your decimal would have to be. Okay? It cannot be there. You actually have to go in and move your decimal. Again, here, you have to move your decimal. You can only have it in 1 digit. You would have to move this decimal back. This is really important. Okay, the decimal is always directly after the very first digit. So it would need to be in these spots. Okay, let's move on. Let's do some problems. So we are changing. This is your standard notation. What you're looking at right now is the standard notation. Okay, you are changing this from standard notation to scientific notation. Okay, so what you need to do is we need to figure out where the decimal goes. I told you the decimal goes directly after the very first digit. The first digit is a 2, so it goes directly after that. Okay? Then, so you write it as 2.37. You do not have to write all these extra zeros, because those zeros end up being after the decimal. But you have to calculate, you have to figure out how far you moved it. Remember, this is a very big number. This is 237,000. That's a big number. So this should be a positive exponent after the 10. Remember, if it's a big number, it should be a positive exponent after the 10. Now we need to count the number of spaces. The decimal started here, even though you can't see it. The decimal always starts at the end. You count 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that tells us that we have to use 5 because we moved it 5 decimal places. Okay, and that's all you do. That's your answer. Again, you have to put your decimal directly after the first digit, and then you count. How far did it move? Since there is no decimal on here, we know it started here. Okay? Okay, if you don't see a decimal, where the next set you can see the decimal and where it starts. This set, there is no starting point, so you always put it at the end on the right side. We're going to count. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this number would be 3. You don't have to write all the zeros if they're after the decimal. If they're after the decimal, you don't have to write the zeros. Times 10 to the, again here, you moved it 5 spots, so it's 10 to the 5th. Now let's look at the next one. We know this one does not have a decimal showing, so we know that the decimal starts here. We have to move it to right after the very first number, the very first digit. So we have to count. 1, 2, 3, 4, 5, 6, 7, 8. And notice these are all positive numbers, positive exponents, because of the fact that this is such a large number. Okay, so it is 4.75. We don't have to write out all the zeros after the decimal, when they're after the decimal, times 10 to the power of 8. Okay, now we're going to look at the numbers that are smaller than 1, that are small numbers. Okay, so again, we need to move the decimal to the right after the very first digit. We are moving it back 1 space. So then we move the decimal to this new spot. So we write it as 3.57. Again, we don't have to write this 0 that's out front. We do not have to write any zeros out front or any zeros behind. But if they're in the middle, you do have to write the zeros. They're just, if they're out in this direction or this direction, you don't have to write them. But if they're in the middle, you have to write them. Okay. Times 10. And what did we go? 1. But since this is a small number, we have to use a negative number. This is small. This is less than 1. It's going to be a negative. So let's look at another one. We always know it's going to be times 10. Since this is a small number, we know it's going to be a negative up here. We put the decimal right after the very first digit that's not a 0, so we don't look at those zeros. We're looking for the very first number that's not 0. And we have to figure out how far do we have to move this. 1, 2, 3, 4. We count 1, 2, 3, 4. Okay, so the number is going to be 2.5 because that's where we moved it to, and the exponent is the 4. Now let's try this again. We have to move it after the first digit that's not 0. Well, the only digit that's not 0 is at 2, so we have to move it all the way over there. So it's 10 to the, and it's a negative, so it's going to be negative. So we have to count 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So this is going to be 2 times 10 to the negative 7. Okay, this is changing it to scientific notation. Next, we're going to look at changing it out of scientific notation. Okay, so here, we're changing it out of scientific notation. This is positive, so we know we have to make a big number. So that means that your decimal is going to move this way. When it's positive, it's going to move to the right because it's going to be a bigger number. You want it to be bigger than 0. Okay? So let's write this out. It's 3.56, and we have to move it 5 times. 1, 2, 3, 4, 5. Well, notice there's these empty spots. What do you think I'm going to add there? Zeros. So my answer is 356,000. So again, this is a positive. We have 4.7. We have to move it 2 spots. 1, 2 spots. Again, we add a 0 there. 470. We have 6. Where does the decimal and the 5 land when it's not there? It's right behind it. So we're going to move it 1, 2, 3, 4, 5, 6. So the answer is 5 million. These were all positive, so we moved it this way when it was positive, so that it can become a bigger number. When they're negative, we have to move them the decimal the opposite direction. Okay, so when it's negative, we have to move it the opposite direction to make the number smaller. So let's do this. We're moving it 5. 1, 2, 3, 4, 5. So again, we're going to add zeros in here. Now there's two ways to write this answer. Most commonly you have a 0 written out in front of the decimal, but that doesn't count as the ones you're counting. There should only be those 4 zeros. Those are the ones that really count. So you can write it like this, or you can just write it without that 0 out front. It's more properly written with the 0 out front, but these both mean the exact same thing. It's just the key is that you don't count this 0 out front as one of the 4 on the inside. Okay, let's try it again. It's negative, so we know it's getting smaller, so it has to go this way. We go that way 2 times. So it's going to be 0.047. Again, you can choose to put that 0 out front if you want, but you don't have to. Here we have a negative, so we're moving left again. This is 5. So we're going to put the decimal after the 5, and we move it 1, 2, 3, 4, 5, 6. Again, we fill in all zeros. There are 5 zeros being added. You can add that 0 out front if you would like, but you don't have to. Okay, last thing we're going to be learning is multiplying scientific notation. Okay, this is why I have the calculator out here. The key is that you start by multiplying these two numbers, 2.3 times 2.7. So you take out your calculator. 2.3 times 2.7 equals 6.21. We always keep it times 10. But the exponents, remember when you multiplied, the exponents always told us to add. You add these exponents, 3 plus a negative 2. So the answer is 6.21 times 10, and 3 plus a negative 2 is just 1. Since the decimal's in the right spot, this is the final answer. Okay, let's look at the next problem. We have 4.53. Again, these first numbers we always just multiply, and we multiply them. 4.53 times 7.31 equals 33.1143. We always write it times 10 to the, we have 5 plus a negative 5. So that's going to be 0. We have 33.1143 times 10 to the 0. The problem is that this decimal is not in the right spot. It needs to be over here. When you move it this way, you're making the number, you have a big number that you're making it smaller. So you have to add 1 because you have a larger number than the 1. Okay? So you're making it bigger, so this is going to be 3.31143 times 10, and you add 1 to the exponent, 10 to the first power. Okay, let's do one more. Hopefully our time doesn't run out. We multiply these two numbers. 5.3 times 6 is going to be 31.8 times 10 to the 3 plus 7. We have to move this over one spot, which would add another 1 to this, so it's 3.18 times 10 to the 11.